So nowadays we have the DRAM crisis. But let's first consider the traditional workload. We don't have too much the data driving spec and stuff, so we can just keep everything in memory. So if we have more data, we just add more DRAM. It's workable. But in AI where everything changes, we need to store more context, more AI chat messages. So in this case, we must have a new way, SSD first solution to handle these challenges. So this is the data from IDC, and we can see there is a huge growth for the AI workload, especially in 2027, there will be a 10x increase in the agent adoption. There is another new opportunity is that the new hardware, the NVMe, now we have very good performance. This is the latest SSD from Micron. It has the very good performance numbers. For example, the random rate has reached more than 3 million LPS. And even more, we can have 8 such SSDs on a single server. So you can have 2 million LPS. It's very fast. It's very close to the DRAM. So this gives us an opportunity to introduce a SSD first architecture to bring the DRAM first architecture where you may need 100 cluster. And now you can shrink it to 10x smaller with just 10 nodes. But more important, the solution must keep the latency very low. But the current solution doesn't work. For example, PostgreSQL is SSD-backed database, but nowadays you still need Redis in front of PostgreSQL. You know why? Because when your hot data cannot fit in your buffer pool, you have a cache miss, and your performance becomes very unpredictable. But our application requires a predictable performance, even on your long-tail latency. The other one is the legacy database solution cannot fully utilize the SSD performance. For example, they use multi-threading and sync I/O. This all generates a very big gap. You can see from the right graph, there is a gap between the current database and the real capability of SSD. So the data solution is we introduce a modular architecture for building a database. We call it the data substrate. It uses several new techniques from the async I/O, coroutine, user space scheduling to get the DRAM class performance with SSD cost. Now I will give some benchmark numbers how we get the memory performance with SSD cost. First one, if you care about the long-tail latency, you can see from the graph, the hardware is 100 gigabytes RAM, but the data set is 2 terabytes. You cannot hold the data in memory. And your workload do the mixed read and write. With random access, we can ensure in your 2 terabytes data with 100 DRAM, we can achieve under 3 milliseconds for your P99.99 latency. This is extremely low, sufficient for your recommendation system, your ad system. Another one, if you care about your throughput, and there is another benchmark, and we can have different data from datasets from 20 gigabytes to 2 terabytes. For 20 gigabytes, you can hold all your data in memory. And from the right graph, we can see we can achieve 600 QPS per node. And when you have 2 terabytes data, all the access is from disk. We still have 300K QPS. This is a very amazing number. Okay, next I will give you a demo to understand what's the difference between the SSD first solution vs the memory-based solution. Is to compare Eloq KV and Neon Cloud. They have the same hardware configurations, and we will compare it with the e-commerce recommendation. So when you have a user request, it will fetch all the items the user buy before, and with this data do the recommendation. So there are a lot of database read for this kind of workload. Okay, so let's do a lab demo. So try demo. Now we have two parameters. The last one is the concurrent users. This is also a concurrent request, the pressure of your workload. And the right is the max user ID. It specifies your working set. How many users do you have? Let's try the initial setup. We can see Eloq KV can get the result very fast, and Neon need to take more than 1 second. And then we can increase the data set from 1 million users. And we can also set the concurrent users to 1,000. There is a 1,000 concurrent requests per second. And we do the recommendation again. And we can say Eloq KV return the result. But Neon needs more than 4 seconds. It breaks the user experience. And if you want to get a better user experience, you must buy more machines on Neon or PostgreSQL. But in the agentic era, you will have much more data than 1 million users because you will have 1 billion agents. And the concurrency is not per user, it's per agent. So we need a SSD first solution in the agentic era. Thank you.